So to start off, a little about me. I'm currently the CERT Manager here at SOC of Ackcent, at Ackcent Cybersecurity, sorry. I used to work a lot in the SOC. I started as a SOC analyst 7 years ago, and then looks like everything is going well, and that's why I'm still here. Probably if it wasn't, I wouldn't be in front of you today. So, also, I participated in several incident response engagements. That's what I'm most interested on currently. And I also passed the OSCP exam recently because I also want to understand how attackers do in order to be a better defender. Moving forward, what will we talk about today? So I will do a little briefing about what's the goal, what's the context of what we are doing in the SOC of Ackcent. And depending on that goal, let's see where we can improve our processes using different standards and frameworks. And starting from that point, we will focus on two different aspects, on the detection and the playbooks that we have on the SOC. And more important for us, it's not only how to improve, but also in this attempt to improve, what went wrong, what worked properly, or what had a different outcome of the expected. And also, last but not least, what's next? What can we further do in order to improve in our services? Before starting with the goal, I think it's needed to understand some context about the company. It's an MSSP, Managed Security Services Provider. We provide security services to several customers. And we are a cloud-based SOC. So we have many detection rules. So just so that you can have a bigger picture of the team, it's about 25 person with several detection rules and procedures. So we will try to improve a little the maturity of those detection rules and procedures. Why? Because we would like to improve the analyst's outcome of the investigations. We would like to ensure that all the analysts are taking into account all the needed steps in order to follow an investigation. Also, we would like to share the same processes among all the analysts, because depending on the analyst, usually what happens is that they might have more expertise on some field, and they can take different steps than others. So we would like to have like a common language and common steps for those analysts so that the investigations have the same or similar outcomes. Also, it's really hard in this field to hire new analysts. So we would also like to make it easier to new analysts to join the team with all those processes, with all those guidelines that they can use in order to investigate anything that comes up. And there you go. Also, it's not directly related with the other ones, but we would like to identify, to be capable of understanding what gaps do we have in our monitoring, mapping those detection rules that we have just mentioned to some known frameworks. So the first standard that we will talk about today, it's just briefly, we will see it. It's the incident handling processes from SANS, if I'm not wrong. NIST has another definition for this standard, and there are several phases. In this case, there are 6. We will focus today on the preparation. We will prepare for anything that might come up in the future. But this preparation will probably be concretely focusing on the identification and the containment of the threats using this mapping and procedures. Regarding the detection, which is related to the identification phase, I would like to mention 2 different knowledge base of rules. The first one is the MITRE CAR. If you're in a team that is starting to create a new SOC, that is building new detection rules, there are 2 knowledge bases that you should really have a look into. The MITRE CAR, it's a repository of rules from MITRE, which stands for Cyber Analytics Repository. And it contains several rules which tries to identify some suspicious behaviors. Here's an example of a detection rule which tries to identify whenever the Windows event logging is disabled on a host. They have many implementations, mostly on pseudocode, but if I'm not wrong, they also have some implementations for Splunk and maybe other CMs. Another knowledge base of rules is the Sigma. There are several repositories on GitHub. You can look for that. And Sigma is a syntax for the definition of detection rules using a common format. And also, there are several other tools that you can use in order to translate those detection rules to other CMs. And you can use them in order to import them in your monitoring capabilities. Here's another example that's also extracted from GitHub. Another thing I wanted to mention on this example is that we have tags defined within the same detection rule. That's something that we will be working on in order to understand what we are monitoring. Here we can see that there's a mapping to the MITRE ATT&CK framework, and it's related to the defense evasion technique. So what we would like to know, we have so many detection rules. We are monitoring several assets from our companies, from our customers, but which gaps do we have on our monitoring capabilities? That's what we would like to identify in order to see where we can improve. And also, we can identify gaps from the companies that we are monitoring and maybe add new sources and add new detection rules or whatever. That's something we can also use for selling to the customers. So what we try to do is to map all the detection rules to a framework. In this case, we mapped the detection rules to the MITRE ATT&CK framework. And we are trying to print all the detection rules to those techniques so that we can have visibility over what's covered or not. The thing is that there's some overlapping on the rules. Here's an example of one rule where we try to identify whenever there's an authentication without using multi-factor authentication. Here we can see that there's some tagging within the same detection rule. It's not the implementation, it's just the definition in this example. And we can see that it's related to several techniques, which means that there might be different detection rules that have mapped different techniques. So what we are doing in order to see the effectiveness of the monitoring of those techniques is to count how many detection rules we have for a specific technique. So that's something we will talk about later. But just so that you're aware of, many CMs out there already provide out-of-the-box detection rules that are mapped against this framework, MITRE ATT&CK. The goal of this presentation is not to define MITRE ATT&CK. There are so many resources out there. It's how we implement those frameworks to our services. So here we can see that we have mapped that detection rule to that framework. Regarding MITRE ATT&CK, there is an increasing adoption on many more vendors, many more products, which is another issue for us because now we have, for example, we work with SentinelOne, and they also have their own matrix mapped against MITRE ATT&CK, which for us, it's kind of difficult to identify what we are monitoring, what we are preventing, because we have to aggregate all this data from all the products that the customers have. So from our point of view, now it's another issue. I'm not saying that they shouldn't do that. It's great. There's increasing adoption using the same framework. But the thing is that from our point of view, we have to aggregate all this data in order to understand if the customer's needs are covered or not. So that's something that we're working on. Apart from that, I would like to mention MITRE Defend. It's a work in progress. I think it's still on beta, if I'm not wrong. But here we can see that MITRE Defend would be for defenders what MITRE ATT&CK is for attackers. MITRE ATT&CK can help you identify the different techniques that attackers use. So in the future, probably we will adopt this and try to map all those detection rules against this other framework. Also, it's cool to have different actions that you can proactively take in order to mitigate threats. For example, you can isolate a host and so on, and you have some predefined descriptions and probably implementations that you can use in order to be more effective during the procedures that you write. Moving forward, we talked a lot about detection. Now we will talk about procedures. So we also would like to improve the way we handle the procedures, the way we write them. So to start off, why do we need procedures? Our current situation is that we started creating procedures for the detection rules that we have, and they were on raw format. The formatting is like dependent on who wrote that procedure. We have many procedures, and we don't really have a scalable way to manage them. So we will try to adopt a standard, which is Cacao. We'll see it later. Because usually what might happen is that we might not be aware of how capable we are in order to manage the different investigations that might happen. What we want to avoid is that we think that we are prepared for something, but when something comes up, maybe you can get a punch in the face. So we would like to avoid that. I just mentioned it. We try to implement Cacao from Oasis. It's just a standard for playbook creation. It stands for Collaborative Automation Course of Action Operations, if I'm not wrong. And this standard defines, let's see the structure. This is the structure of a Cacao playbook, which includes some key components. For example, we have the metadata, such as the name, description, whether if it's valid or not, the workflow, which is for me the core component, the steps that the analysts have to follow. Apart from that, we have targets, who has to do some specific action, and so on. Data markings, such as you can define the TLP as well. Extensions, you can add other definitions from other standards, references, whatever, and digital signatures so that you can digitally sign the playbook. So it's fully on JSON. It's machine readable. It will allow us in the future to be able to create scripts or tooling around them so that we can parse automatically several stuff from the playbooks. Anything that is written there is accessible, so that's a good start. And also it's really scalable. We will see 2 examples of this implementation that we're doing, this migration from raw format playbooks to a more structured playbooks. Here we can see an implementation of what it would be like, the implementation of the metadata of a playbook. Here you can see the basic fields from this playbook, such as the name, description, the playbook types, which is actually a predefined list of possible values, who created it, whether if it's revoked or not, if it's valid, and so on and so forth. Also, you can add external references if, for example, in this case, we're using it to refer to the previous playbook that we had that has been migrated to this format, so you can use it as a reference. Regarding the workflows, which is, for me, the main part of the playbook, because in the end, it's what the analysts will follow. Here's an example. It's a dictionary on JSON. You have different types of steps, which will help you being more scalable and drawing different graphs depending on your needs. And also, it's worth noting that there are some, you can define which target has to do some specific action, and also, you can pass variables among the different steps. For example, if in one step you have to look up the maliciousness of an IP or a hash on VirusTotal or whatever, that output might be an input for another step. And that will help you during the procedure. So we have started doing this migration, but we had an issue. Everything is written in JSON. We have no visibility over if we are doing it right or wrong because we can't validate the syntax properly. What we've done is to read the Cacao definition, the standard. We try to implement it, but we do not have this graph representation, which is really easy for the analyst to follow. We do not know if there's a typo, for example. So what we did is to implement a basic functionality, a basic tool that takes these playbooks from Cacao and creates the graphic representation using Mermaid, which is a framework from of JavaScript, if I'm not wrong. And GitLab and GitHub is capable of rendering this diagram. We'll see an example. Here's an extract of the script where we can see that there are some different types of nodes depending on the steps that we have defined, so that we can be able to easily visualize the steps. And now we will see, this is the example that Cacao defined on the standard that's extracted from the definition and passed through Cacao to Mermaid, the script, which actually you can find on GitHub. There are those examples as well, so if you look on GitHub for Cacao to Mermaid, you will find it. And using the example that Cacao did against that script, here we can see the graphic representation, which is easily to consume by the analysts. So that's our goal, to have some predefined procedures using that standard and have this easily to visualize result. We'll see now another example of this migration, which is the EDR detection workflow, which aims to define some decision planning depending on the different results that we're seeing. This is much bigger, so I just divided the playbook in two. We can see that what we're doing, the decisions that we take when something comes up from the EDR that we work with, which is Sentinel-1, is that we start by setting the status of this threat as in progress, which means that there's someone investigating this threat. Then the second step, which is a single one, should be another playbook, which defines how to analyze this detection. It's defined as a single step now, but in the future we will have this other playbook that we can actually embed inside this playbook. Then we will have a verdict from the analyst, which may be that he's not capable of investigating this threat and probably has to escalate the case. It might be a false positive or a true positive. So depending on those decisions, the analyst will know which way to follow. Okay. So moving forward, if it's a false positive, probably if it's a recurrent threat that is triggering on a host, maybe we should ask the customer whether if an exclusion should be added or not. If it's a known exclusion, for example, for a software which performs backups or whatever, maybe we should add an exclusion directly. Or if it's a single occurrence, it's not malware, and it has been mitigated, just ignore it. We'll see now in the following slide. And what happens if it's a true positive? That's when there's more problems, usually. The impact detected node is an if condition defined within the playbook. So you can see that it's slightly different because it says on true or on false. It's binary. If there's impact, if there is an impact, we will see if it's an isolated threat. And if it's not, we'll probably report to the customer and start moving and doing all these processes for the incident response engagement. So here we can see that there is a reference to a playbook. The report to the customer playbook depends on the customer that we are working with, because as a reminder, we are an MSSP. We have several customers, and the communication depends on those customers. And depending on whether if it's urgent or not, the contact will be different. Another example, now we will see how to handle an email that has been reported, how analysts should handle those emails that have been reported. Here we can see that we have defined on the playbook of Cacao different types of steps, starting with a parallel step, which has different connections to other nodes. And then we'll perform several actions, such as investigating the headers and so on and so forth. Here's the output of the script that is automatically rendered by GitLab. Actually, we are using a wiki which is based off GitLab pages on our custom deployment. And it's also capable of rendering it with a theme, so you can use that, and it's easily to access for the analysts. And this would be what the analysts see, and that's what helped them in order to know which actions to take, what to decide, and so on and so forth. So here in this example, we see that we start with an email, that we extract the different indicators. Here we define the indicators that are the header analysis, the content, if I'm not wrong, and the attachments. And then, for each of those components, we will perform the needed analysis. For example, for the headers, we will analyze the SPF, the KIM, the mark. We will also analyze the custom headers that providers might have added, such as the SCL, BCL, etc. And also, on the other hand, we'll analyze the content of the email. We'll see the intention, what are the goals of the people that is sending those emails. And last but not least, the attachments. We'll try to gather all this information about this procedure, about this email, and reach to a conclusion, which might be the conclusion that is malicious or not. And depending on the decision that we take, we will follow some steps or others. Okay? So the idea behind this is that we are trying to define playbooks using these standards so that we can later on use them and have an easy representation and graphical representation. So lessons learned from this migration and the detection part. We found that there are so many detection rules that now are mapped, but all the vendors are adopting the MITRE ATT&CK framework. Probably in the future, we will adopt also the defend when it's ready. But from our point of view, from the MSSPs, in order to understand what we are protecting from our customers, we have to aggregate all this information on a common format so that we can understand which are the gaps or the risks that are not monitored or protected by ourselves. Apart from that, we noticed that we went on tryhard mode. We read the definition from Cacao and started writing JSON. That's not really practical if you try to. So it's recommended to use proper tooling in order to create all those playbooks. So that's something to take into account. Although we created some script in order to parse the content and do the graphical representation, usually it might be better to have some tool that directly creates the graph and you don't have to touch the inner JSON. What's next? As I mentioned, we would like to continue doing this mapping, probably using Attack Navigator and then in the future defend. Also, by using Cacao, we would like to start sharing. I think that many people here probably have the similar issues on how to handle incidents, have probably similar processes that we could start sharing and knowing how to better handle. So I think that adopting this standard, Cacao, it would be really great for the community so that everyone start sharing and so on. And also, if we start using standards and frameworks, it will help us in the future to perform potential automatic report generation based on the definitions that we have on the MITRE ATT&CK techniques or on the MITRE defend. And the ultimate goal would be to, when you do an investigation, you know the steps that you have followed, which are mapped to some definitions, and maybe add them to an automatic report. So that would be the final goal. So that it's better for the documentation. That's a topic I've been trying to research and we are working on. I would appreciate if anyone has some tips, recommendations, want to discuss anything, just don't hesitate to stop me by the corridor or whatever. And if you have any questions, please.
Questions for Guillem?
Hi, very nice presentation, and I've been there, and I think I can help you. We have some of the solutions to your problem. We have a Cacao visualizer, so you can edit. It's fully validated, so we are basically certified by the standards, so you don't have to do all that kind of visualization and editing. We have also planning to. It's all open source. I'm not going to try to sell you anything, by the way, but we need beta users like SOC teams like yourself that can actually give us some feedback. The other problem we found with Cacao playbooks is that you're using the human to follow like a machine, but like what you really want to do is to try to remove him from the equation, because like if you're analyzing an email, you want to maybe use
Yeah.
OpenC2, right? So like, which is another standard. You didn't mention that, but you can basically run the playbook as much as you can with automation and XDR solutions, whatever you want to buy, and then say, well, this task now requires like human supervision that you can through do via automation, and then you continue to do that. Yeah, so maybe we can talk more, but there's a lot of interesting points that we can help you. Open source. Okay.
Cool, thanks. Actually, I didn't mention it during the presentation, but the goal of adopting this standard is that Cacao is also capable of defining automatic steps. So now the actions that we did is to migrate the playbooks from raw format and unformatted to a standard, and then the idea is to automate as much as we can. So little by little, we are trying to go there, yeah.
Other questions? Comments? Sure, go ahead.
I'm very into these topics. Very excited. What's your plan with Defend? So one of the things that is missing in the community is the equivalent of us, like, I don't know, we call it a reverse sigma. So like, you can match the attack and defense, but like ideally you want another tool which will compile an OpenC2 command, or something that will basically provide like change policy firewall, a natural command that will do that, because that's missing. There is nothing like that in the community. But do you have any ideas and anything like that?
Actually, Defend is still a work in progress.
Yeah.
A work in progress.
Yeah.
They are open to contributions. I have browsed through their Slack and so on.
Right.
And looks like their goal is to be able to reach all those actions. Yeah.
Yeah. So it would be great, right? You
Yeah,
basically
it would be
you,
awesome,
you have fully automation.
Yeah, that's yeah.
And last question: do you use Kestrel? Are you adopting Kestrel as a threat hunting language, or is it something?
No, we haven't. That's
Okay.
something that we should look into.
Yeah, I'm also in that community, so like, I can give you some more ideas.
We will talk later.
Okay.
Yeah.
Thanks for everything.
Thank you. Other questions? Final remarks?
What?
Any final remarks or comments?
No, that's fine for me.
Well, then would you please join me in thanking our speaker this morning?